this example, we would like to construct a 90% confidence interval we would like to know the sample size that is required to construct a 90% confidence interval such that the margin, the true population proportion is within 1% of point estimation. Notice, unlike the previous example, we do not know the point estimation, which means we have to guess. Nice, isn't it? And it turns out that the best guess without any information will be using 0.5, somewhere in the middle. That is a good starting point. Margin of error is, we want it to be 0.01. And alpha over 2 equals 1 minus 0.9 over 2, which is 0.05. And z alpha over 2 equals negative inverse norm, 0.05. Why is that? Let's cover this. So we are going to use, according to central limit theorem, I'm going to use normal distribution to estimate the population proportion. Here is the mean, and z alpha over 2 is this z-score over here, and here we have negative z alpha over 2. And because normal distribution, the shape is symmetrical, we could use the negative number, the negative z alpha over 2, to find the actual number we are looking for, z alpha over 2. Why is that? Because using your graphing calculator function, if you know the area to the left, in this case is 0.05, then you could use the inverse norm to find the corresponding z-score and flip that over. That's why I put that negative sign in the front. Negative becomes positive. I will have the z alpha over 2. And the sample size equals z alpha over 2 square times, when we know the point estimation, we will write down p hat times 1 minus p hat over here. But because we do not know anything about population proportion, we use 0.5. If I put in 0.5 over here and 0.5 over here, that will give me 0.5 times 0.5, and it becomes 0.25. So go ahead and put down 0.25 in your formula sheet. From now on, you know that if you do not have a reasonable estimation or estimate for population proportion, you just put 0.25 over here. And here I have the margin of error square. So that is the formula. In practice, in this question, I will put in inverse norm. Notice that I dropped that negative sign because negative square still negative. Times 0.25 over 0.01 square, because that 1% off, within 1% of the true population proportion. type everything into graphing calculator, I have 6763.85, and it goes on forever. And remember, when sampling, you always round this number up to the next integer, regardless what comes after the decimal point. So the answer is 6,765.